In this video, I'm going to compare some terms that usually get interchanged between each other because there's some overlap, but there are a few subtle differences that I'm going to show you. So these are solutions versus roots versus zeros, and finally x-intercepts. So let's start off with talking about solutions. Solutions are the values for the variables that make equation or equations true. So in this example right here, we have a system of two equations. One of them is a line and the other one is a quadratic. So what we're going to do is substitute one equation into the other, expand one of the sides, and because it's impossible to isolate for x because there's so many terms with x's, we're going to use the property of 0. So we're going to bring everything to one side, so one side is 0. We have this equation. And when we factor this equation, we can use the property of 0 to find that x equals -7 and x equals -1. Then to proceed to find the y values for this system, we can substitute these x's into either one of the equations. I'm going to substitute into equation number 1, and these are the corresponding y values. So the solution set for these two equations, or the system of equations, is these 2 points, x value, y value, and then this x and y value as well. Now, to compare to the other ones, when I had to resort to solving an equation equal to 0, this I call the related equation. This related equation could be thought of as a polynomial expression, x squared plus 8x plus 7. And so you could say that these solutions that we got for x's could be also called the roots of the polynomial. For polynomials, there is a fundamental theorem of algebra which states that there are as many roots in a polynomial as there is the highest degree, or the degree of a polynomial. So those roots could be real or complex. If they're real, they could be rational, so integers or fractions, or they could be irrational, so that could be with square roots, like square root of 5, or they could be imaginary, like square root of a negative number. Next, we could also say that this related equation, instead of calling it an equation, we could call it a function. So in grade 11, you would learn that this right here, f of x, is actually just a replacement for y equals. So it's an output variable, and we have a function name for it. This function is called function f, but we can call it any other name. So if we resort to calling this polynomial a function, then these values -7 and -1 would be called the zeros of this function. So to recap, zeros are values of the input variable that create a 0 for the output variable in a function. So the input variable is the x, and the output variable is this f at x, which we call the y. And so functions have zeros, polynomial expressions have roots, and then system of equations, or just an equation, have solutions. What is it to have an intercept? If we were to graph, so the green is this line right here, and the black is the parabola, then the points of intersection would be the solution set right here, so -7 and 25, and -1 with 1. So those are points of intersection. How do they relate to x-intercepts? Well, if we take the related equation, and I'm going to draw it in a dotted line here in blue, so this is right here, so this is the related equation plotted, then what you should notice that -7 and -1, when you plot that, the x-intercepts happen to be the same x values as the POI of the original system. So the x-intercepts are the x values of where the graph touches the x-axis, and those are the 4 different terms in relation to this example. Let's do another example. Imagine you were told to solve this equation. So once again, because there's many terms with x's, let's have one side of this equation to be 0, so we can use property of 0. So this is a cubic polynomial, And there's ways to factor a cubic polynomial, but for this particular one, factoring by grouping actually works really well. So if we group the first two together, we'll have x squared in common, and 2x minus 1 is left over. And if we group the last two, positive 9 could be pulled out, and we have the same bracket as this one, which is good news. And if we factor this, we will get this equation. And then we can use property of 0 to say either this factor is 0 or this last factor is also equal to 0. Then we solve. So you can put 1 to the other side, divide by 2, you get x equals 1/2. Solving this one, we have to move 9, so subtracting 9, then we need to get rid of squares, we do square root, but square root of a negative does not exist in real numbers. But you can actually proceed to solve this with imaginary numbers. So first of all, root -9 is the same thing as root 9 with root -1. Root 9 is just going to be a 3, and square root of a -1 is the I for imaginary number. So how do these terms relate in this question? So we can say that the solution set is 1/2, 3i, and -3i, because those are the values that make the equation completely true. We can also say that this related equation, we can say that this related polynomial expression has one real root, 1/2, and two imaginary roots, plus or minus 3i. If we wanted to say that this is a related polynomial function, then we would have to say that this expression is equal to some output variable that we could call f of x. Then in that scenario, we can call these roots actually zeros instead. And how does that relate to x-intercepts? Well, if we took this function and graphed it, so x-axis, and then this is the output f at x, we will see that there is only one x-intercept. We cannot plot imaginary numbers on the x and y coordinate grid. So this is the true difference here, that there is no overlap. We cannot say that plus or minus 3i actually go on this graph. I hope this was helpful.